Hello, wonderful humans. We're going to dive into these notes on one-step equations. So this is a 6th grade TEK 6.11, which is one-step equations, writing and solving, and all things one-step equations. It is also in 7th grade, but we actually do 2-step in 7th grade, which will be TEK 7.11. Make sure you put a date on your paper and what unit we are in, so that way you can use it on the unit test. Okay, some vocab. We have inverse operations, which defines as the opposite operation that undoes what is being done, which the opposite of multiplication is division, and the opposite of subtraction is addition, in addition to a subtraction. Meaning, if I multiply by 5, like let's say 4 times 5 is 20, 20 divided by 5 is 4. Like you see how it undoes each other? You know this. Then we have reciprocal. You'll hear me say that, and you'll hear a lot of your teachers say that. And that is the value flipped where the product would be 1. So, for example, the reciprocal of 1/3 is 3 over 1. Because if I multiply 1/3 times 3 over 1, I would get 3 over 3, which reduces to 1. And the reciprocal of 2/5 is 5/2. Because if I multiply 2/5 times 5 over 2, I would get 10 over 10. Which reduces down to 1. So the reciprocal is just the number flipped. All right, you have 4 steps. And the first step is simplifying the expression only if necessary, which it will not be on today, but you will come across some algebraic expressions and equations where you'll need to simplify by combining your like terms or distributing a number if it needs to be distributed, outside the parentheses. Step number 2 is identify the operation happening to the variable. What do you see happening? Step number 3, do the opposite to both sides. Lastly, number 4 is check with substitution. We will always do this because sometimes we'll do math and then we'll forget our negative sign or put our decimal in the wrong place, and then we have the wrong answer, and we'll know we have the wrong answer because we'll substitute it in. All right, guys, let's actually just jump into these examples. Example number 1, what do I see happening to x? Well, I see that there is this fraction bar here, which means divide. So I see division. Therefore, I'm going to do multiplication. And I'm going to multiply both sides by 2. So we see here, these would cancel each other out. So all the math that I have to do is 10.5 times 2. Now 10.5 times 2, we should be able to do in our heads, but in case we don't, or in case we can't, we'll work it out. 5 times 2 is 10, carry the 1. 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2. I see that my decimal is 1 in, so I'll go 1 in, which means that x equals 21. Now to check it, I am going to substitute it back in for x. So 21 divided by 2 should equal 10.5. Let's check. So I'm going to put 21 inside, 2 outside. 2 can go into 2 one time. 2 can go into 1 0 times. Bringing down that 0, 2 can go into 10 5 times. Well, it checks out. Therefore, 21 is my answer. Number 2. 4.5 plus n equals 8.3. What do I see? I see addition. So what am I going to do? Subtraction. Subtract. And I'm actually going to start writing this off to the side, so I actually have some room to work it out here. Yeah, iPad's pretty cool, guys. Okay, so I'm going to subtract from both sides. So 4.5 minus 4.5 and 8.3 minus 4.5. So we see how this cancels out. I'm going to bring down this n. And now I'm going to do some subtraction. So 3 minus 5, I can't do that, so I got to borrow. 13 minus 5, I can do that. That's 8. 7 minus 4 is 3. So n should equal 3.8. So let's check it. by substituting it back in. So 4.5 plus 3.8 should equal 8.3. Now, I can, but I don't like to do that kind of addition horizontally. I like to do it vertically. So rewrite this as a vertical to check my answer. 5 plus 8 is 13. Carry the 1. 1 plus 4 is 5. 5 plus 3 is 8. Comes out to 8.3. Therefore, 3.8 is my answer. Done. Moving on to number 3. Number 3 says 4/5 of a number is 12. Well, I see a key word here of, here's my number 4/5. Here's a number, but we're going to put variable. Is a key word, and 12. Do you see how I'm cubing this? And every single part of this sentence is necessary. So let's translate it to math. 4/5 of means times a number. I get to choose any variable I want to represent this number. I'm going to choose n because n starts with, number starts with n. Is means equals, and then 12. So I literally just translated 4/5 of a number is 12 to math symbols. That's all I'm doing. Okay, what do I see? I see multiplication. But I see multiplication with a fraction, which means, yes, I'm going to do division, but there's a shortcut, guys. When you see it being multiplied by a fraction, we really just multiply by the reciprocal up here because we're trying to get it to 1. So we see here, we're trying to get our fractions to 1. So I'm going to multiply both sides by 5/4. Because we see that these cancel each other out, right? So I would just have n on this side. Well, there will be an invisible 1 here, but 1 times anything is itself. Now I'm doing 12 times 5/4. I am going to cross reduce. So I'm going to cross reduce my 12 and my 4 because you know that this is over an imaginary 1, right? My 12 and my 4 can be reduced by 4. So this becomes 1 and this becomes 3. And then 3 times 5 is 15. Now, last step, we are going to check to see if my number actually is 15 by plugging it back into my original equation, which is 4/5 times 15 should equal 12. So let's do 4/5 times 15. I'm putting it over 1. Should equal 12. So let's cross reduce the 5 and the 15 by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. Now 4 times 3 is 12, and 1 times 1 is 1. Therefore, it equals 12. Checks out. Therefore, yes, my answer is, in fact, 15. 4/5 of 15 is 12. All right, problem number 4. Guys, if I'm going too fast, just make sure you ask your teachers questions. I know that I am going fast because this is a 6th grade standard. I'm just trying to refresh your memory. So 12 subtracted from a number is 8.75. So I see 12. I see the word subtracted from a number is 8.75. So 12 subtracted from a number is 8.75. If you're thinking, hey, Miss Palmer, you wrote that wrong, you're right. And I did that on purpose because I want to show you why this doesn't work. This is not 12 subtracted from n. This is n subtracted from 12. Do we see that? Like I'm taking n away from 12, not 12 from n, which is why I need to split these two. And it's very important, you guys, because it changes my operation. It changes what I'm doing. Now that I've written it right, I am taking 12 from my unknown number should equal 8.75. So let's go back to our steps. What do I see? Subtract. what am I going to do? Add. So I'm going to add 12 to both sides. So negative 12 plus 12 is 0, cancels each other out. That's kind of the point of that. I'm going to bring down that variable, bring down my equal sign. And now I'm going to add 8.75 to 12, which actually comes out to 20.75. Now let's check our answer by substituting it back in, making sure that 12.75 minus 12 equals 8.75. Let's check it over here. So 20.75 minus 12 should equal 8.75. So let's bring that down because you guys know that 5 minus 0 is 5, 7 minus 0 is 7. Bring down my decimal. Here I am borrowing. 10 minus 2 is 8, and 1 minus 1 is 0. So that checks out. Therefore, n does equal 20.75. All right, guys, last one. Number 5. Snow is falling at a rate of 2.5 inches per hour. At this rate, how long will it take 8 inches of snow to fall? Now let's go back in and cube it. Snow is falling at a rate of 2.5 inches per hour. At this rate, how long will it take 8 inches of snow to fall? So I need to figure out what I'm doing here. I see the 2.5 per hour. And I see the 8 inches of snow that I'm trying to get. So per in math means times, right? So I'm doing 2.5 times h, right? The amount of hours until I get to 8. I mean, right? Like I'm trying to figure out how many hours. That's got to be my variable because I don't know how long it will take. I'm trying to figure that out. That's why it's unknown. And I use the variable h because that's what hours start with. And I know it's multiplying because of the word per. So 2.5 times the amount of hours, some amount of hours, will eventually get me to 8 inches of snow. So what do I see? I see multiplication. So what am I going to do? I'm going to divide. Yeah. So when I divide, I use the fraction bar. You'll see me using that a lot because I love the fraction bar. It's a lot easier than, the line with the 2 dots. So 2.5 divided by 2.5 is 1. They cancel each other out. Now I need to figure out how many times 2.5 goes into 8. That is not something that I can do in my head. That's a lie. I can. However, for your sake, I'm going to work it out. 8 goes inside the box, and 2.5 goes outside. Let's make my divisor a whole number by moving the decimal to the right once, doing the same thing to my dividends, pulling it up into the quotients. Now I've got 25. Now 25, every time I think about that, I think about quarters. Now how many quarters will fit into 80? Well, off the top of my head, I know it's 3. Whoop. Wrong thing. I know it's 3 because 3 quarters is 75. Bring down that 0. How many quarters are in 50? Well, 2. Then 2 times 25 is 50, and now we're done. So h equals 3.2. So it'll take 3.2 hours, which is not 3 hours and 20 minutes. It is 20% of 60? 3 hours and 12 minutes. It will take 3 hours and 12 minutes for 8 inches of snow to fall, going at the rate of 2.5 inches per hour. Now for me to check this, I'm going to do 3.2 times 2.5. And let's do it over here. 3.2 times 2.5. 2 times 5 is 10, carry the 1. 3 times 5 is 15, plus 1 is 16, 0 placeholder. 2 times 2 is 4. 3 times 2 is 6, add it up. 0 plus 0, 0. 6 plus 4 is 10, carry the 1. That's 8. I'm going in twice. Yep, comes out to 8, which means 3.2 is my answer. All right, beauties, there we have it.